Okay, this is lesson number 3. Today we will calculate the measure of an inscribed angle and then calculate the measure of an intercepted arc. So similar to what we did in the second lesson, this is going to be, again, angles inside of the circle, but they're going to be on the circle. That's what an inscribed angle is. And then the intercepted arc is the arc formed by the two rays that make, or the two segments, I guess, that make the angle. So let's go ahead and take a look at some vocab. So again, an inscribed angle, that is going to be an angle that is on the circle. So it's going to look like this. So this is the inscribed angle where the vertex is on the circle. The intercepted arc is going to be the arc that's formed by those two segments. Okay, an inscribed polygon is a polygon whose vertices are on the circle. So those would be the vertices. It's like a bunch of inscribed angles together. A circumscribed circle is the circle that's around the polygon. So the inscribed means it's inside. The circumscribed is the outside circle. Okay, so measure of an inscribed angle. So we're going to go through a few different ones of these over the next couple lessons. And the kind of the pattern that you're going to see is you're going to see a half with a lot of them. So the angle measure is half of the arc measure. So the angle measure that's located here, that's going to be half of the measure of the inscribed, or the intercepted arc, excuse me. So this arc, whatever that measure is, the angle is going to be half of it. So if this is 100 degrees, then the angle is going to be 50 degrees. Okay, so let's take a look. It says find the indicated measure in circle P. So example 1, part A is find the measure of angle S. So here's the angle we're looking at. That one's angle S. So if I highlight the arc is 60 degrees. So the measure of angle S would be 30 degrees. Part B says find the measure of arc RQ. So if I switch colors here, arc RQ is going to be this arc here. So if I look at QS, 37 times 2 is 6074. And because RS goes through the center of the circle, that means it's a diameter. So if I take 180 minus 74, it's going to give me 106 degrees is what's going to be left for RQ. So the measure of arc RQ, oops, not angle RQ, is going to be 106 degrees. Okay, so again, that one was a two-part question. You had to find this arc first. Using the 37 degrees, you double it, and you get 74 degrees. And then you know that because RS is a diameter, you know that RQS is a semicircle from the previous lesson. So RQ, you can just take 180 minus 74, and you get 106. All right, let's go on to the next one. Find the measure of an intercepted arc. So find the measure of arc HJ and the measure of angle HGJ. And then what do you notice about angle HGJ and HFJ? So the first one, I'm going to find the measure of arc HJ. So here's HJ. Again, the angle measure that intercepts that arc is 39 degrees. So if I double that, the measure of arc HJ, 39 times 2 is 78. Then it says find the measure of angle HGJ. So here's HGJ. And if this is 78, that angle also intercepts that same arc, so half of 78. The measure of angle HGJ is going to be 39 degrees. And then it says, what do you notice about HGJ and HFJ? Well, those are equal. Or in this case, because it's saying angle, I mean, technically that's the congruent. They should put the measure in front of those. But those measures are equal because they have the same intercepted arc. So that's a property that you want to look for if your angles, so this is theorem 10.8, if two inscribed angles of a circle intercept the same arc. So angle D and angle C both intercept arc AB. Then you know that those two angles are the same. So angle BCA. Okay. So again, it's just saying if the two angles intercept the same arc, you know those two angles are going to be the same. So name two pairs of congruent angles in the figure. So if I highlight arc PQ, so angle PRQ is congruent to angle PSQ. Another one that we could do, if we highlight arc SR, we could also say that angle SPR is congruent to angle SQR. So those would be two pairs of congruent angles that we know, again, because of the arcs that they intercept are the same. Okay, question 1, just a quick review of what we just got done doing. Find the measure of angle GHJ. So that's this angle here. So if the arc is 100, then the angle would be 50 degrees. Number 2, the measure of arc CD. So again, I'm looking for this one. So I have the angle here is 40, so if I double that, that's going to be 80 degrees. And the last one, find the measure of angle RTS. So RTS is this one here. Notice it intercepts RS where the angle Q is, so that's going to be 31 degrees. Those are going to be congruent because they intercept the same arc. Okay, theorem 10.9, if a right triangle is inscribed in a circle, then you know the hypotenuse is the diameter. Reason for that is if you have an inscribed angle, if you double it, 90 doubled is 180 degrees. So you know if it's 180 degrees, then it has to be the diameter. Okay, so the measure of angle ABC equals 90 degrees if and only if blank is a diameter of the circle. So in this problem, it would be segment AC is what they were looking for. Okay. 10.10, the quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. And again, the reason behind this one is if I look at this angle here, that intercepts this arc. And then if I look at, I'll change colors here. If I look at this angle here, change colors here, highlighter, that intercepts this arc here. So because that takes care of the whole circle, that's 360 degrees, and the relationship of the inscribed angles is always half the angle measure. So if both of those angles make 360 degrees, half of 360 is going to give you your 180. So that's just where that theorem comes from. You can look at it in multiple ways when you do these types of problems, and then in the notes or in the homework assignment. So if we use that property that we just got done saying, so find the value of each variable. If I find x first, they just got done saying that the opposite x plus 88. Those have to add up to 180. So if I subtract that, x is going to be 92 degrees. And then the y plus 100 has to equal 180. So then y would equal 80 degrees. Again, there's multiple ways that you guys can go through that. The fastest is going to be using that theorem that they just got done talking about. Okay, part B, opposites. So 3y plus 3y has to equal 180. So 6y equals 180, so then y equals 30. And then the other one, 8x plus 4x equals 180. So then 12x equals 180, so x equals, what are we looking at, 15? 10, yep. I should have a calculator handy. Okay. Next one, a right triangle is inscribed in a circle. The radius of the circle is 5.6 centimeters. What is the length of the hypotenuse of the right triangle? So if a right triangle is located in a circle, so if I draw that real quick, let me turn my shapes on here. I think it's this one. Oh, look at that, perfect circle. Man, I'm good. If a right triangle is in a circle, one of those previous theorems said that that hypotenuse has to be the diameter. So if the radius is 5.6, whoa, hope that doesn't make any of you guys sick. If the radius is 5.6, then you just double it, so that'd be 11, come on, 11.2 centimeters would be the hypotenuse, because the hypotenuse would have to be a diameter. Okay, and then the last one, find the values of A and B. So again, if we look at that previous theorem, opposite angles, 5A plus 90 has to equal 180. So 5A equals 90. So A equals 18. And then 4B plus 96 equals 180. So then 4B equals 84. So B would be 21. Again, you're looking at in a inscribed polygon, your opposite angles are going to be supplementary. They're going to add up to 180 when you do it. Okay? So that is inscribed angles. Key to this lesson is when the angle is on the circle, it's half the measure of the arc. The last lesson, when the angle was at the center of the circle, so when we did questions like this, this was your previous lesson. When the angles were central angles, if this was 40 degrees, then the arc was 40 degrees. Today, the key to today's lesson, that's more of an oval, but we're going to call it a circle, is when the angle is on the circle. If this is 40 degrees, this is 80 degrees. So central angles are when they're at the center. Inscribed angles is when it's on the circle, so it's in, because we're going to talk about another set of angles excuse me, that are formed with tangents and secant lines in the next few days. So just remember that these are your first two different sets when you're looking at them. Okay, remember, if you guys have questions, office hours are from 4 to 6 every day. You guys can log in to Schoology, and I have the link right on that homepage. You can click on that, click join, and you can ask questions there. Or you can shoot me emails, and I can access your guys' OneNote, and we can look at everything from there. So go ahead, take a look at the homework assignment, get that done. those will be counted for points. So just, again, it's already preloaded in your OneNote, so you don't have to worry about